Hello. Sorry for my English. It's not easy to speak English in England, so I will try to do my best, really. I'm one of the two founders of this little company, little but growing company. The company work only for foundry business, cast iron mainly, and we founded the company in 2002. At the moment, is a global company, little but global. We have our own headquarters in Germany and the US and in China too. It's a strange company if we compare our company to, say, the other equipment manufacturer in the foundry business. We are, since the beginning, very focused on IT, and we like to invent new things. Okay, so if you see the product portfolio we have is incredibly wide. No other company with the same size have this big amount of products. So we cover all the, we have, say, 4 ranges of product. One is named TE-TEC, and cover all the product connected to the liquid iron. Okay, so the thermal analysis process control system, but also automatic crane for charging raw materials, all the ranges of dosing machines for base iron, for ladle, cored wire station, automatic aerial transportation system for ladle, in-stream inoculation devices, and other tools that we will see. The other, say, area is called the arena, and cover everything is after the core shooter. So automatic deep tanks, drying ovens, say, coating preparation plant, and handling system for cores. And in last year, we have also, probably you know, the area in which we have the company is Venice, and we are just 10 kilometers far from Maus. Maus, probably you know, was a company that was producing, the first company to produce grinding machines. And Maus collapses a few years ago. Say many of these technicians we hired, and we are creating a new company, totally controlled by us. The name will be Automatech. At the moment, is only a business unit inside ProService, but it will be a separate company in 1 or 2 years maximum. So, and we have joined our, say, know-how in terms of IT and the process of foundry together with their know-how about the grinding. It's a growing company at the moment. Our turnover is around 11.5-12 million euro, and we are more or less 50 people, 90% engineers, divided in all the different engineering fields. So we have mechanical, IT, electronic, robotics, vision engineers, and metallurgical and process engineering. Okay. So yeah, this is more, is a little bit wavy, but yes, on the left you see the places in which the company are. So US, Germany, China, and Italy, and also the other companies that we have. Eologica is our IT company. Analytics Hub is a company that is also owned by us, is a data science company, and Automatech is the grinding company. Okay. So why all these ranges of product? Because at the end of the story, the leitmotif is always the same: sources of variance. So we know Trevor because since 2004 up to 2015, we worked as an engineering company of Fosico. Okay, so we developed for them some machines like or processes like the converter, ICME converter system, or other solution like, for example, in the in-stream inoculation device. And we have introduced inside Fosico the thermochemical analysis system. So when in 2015 we have closed all the agreements with Fossico, and we develop our sales network, and now we are working totally independently. But the idea is always to search for sources of variance inside the process. This is a clear, it's very clear. So there are not only, it's not only important how wide is the Gaussian curve for each process, but it's also the alignment. So if you treat different phases of the process differently, at the end the total variance is very wide. Okay, so as an example, we can see clearly this variance in the base iron. Okay, the base iron is the most important source of variance in the foundry. Sources of variance are what you do for charging the furnace. How do you manage the charging process? How do you manage the correction, the ferroalloy correction in a solid state? How do you manage the melting, and how do you trim your iron, and how do you correct in ladle the iron? So normally what we have seen in the years is that it's clear for everyone that is a dynamic process. Okay, but very few foundry, they correct and they approach the correction in a dynamic mode. Okay, so they follow the same recipe, but everyone knows that if you charge one material or the other, the result will be different. Okay, but at the end of the story, for many reasons, because there are not the right tools, or there are procedures inside, normally the reaction in correction is very static. Okay, so what we have also in stream inoculation is a very easy phase of the process, very simple but very effective. So it's the cheapest machine that probably you have in the foundry. Everyone knows that if this machine doesn't work properly, you can have big problems. But from the equipment point of view, is not treated. This is not approached correctly in the foundry. Okay. So basically, I go quickly because it's a very long presentation. Basically, the presentation will start from base iron. So I will show our latest equipment, trying also to show some videos. And what is the difference between the traditional methods? Okay, so the first machines that we will see will be this Ithaca charge. All the name of the product use Ithaca on this side of product. Okay, and the dosing machine is Ithaca OptiDose. So Ithaca charge is an automatic crane. Okay, it's basically a CNC machine with a dual encoder for each axis. It's a normal crane, okay, a little bit more powerful compared to the standard. The first machine that we have installed on the Z-axis, just to understand, for 32 tons per hour charging, not use a 90 kilowatt only on the Z-axis, so just to understand. It's a very fast machine. This machine play different role in the foundry. So normally we have three working modes: manual, automatic, and leveling. Okay. The automatic, basically you select the recipe and the charging crane automatically charge the charge cars totally automatically. It is possible to identify a specific portion of the charge car to be filled with a specific material. So if we want that this specific material falls down into the furnace for first to improve the induction, we can. Okay, so the leveling function is another important function of the system. When the crane is not used for filling the charge cars, normally can automatically homogenize the distribution of the material inside the bunker. Every bunker is divided in 6 positions, and the magnet of the crane uses the Z-axis as a scanner, because there is an encoder on the Z-axis. So when the magnet touch the material, automatically we understand the level, the height of material and we can also say define the distribution of the material in every single bunker. Okay. It is possible to use the charging crane automatically also for moving material from a position to another position, for example, from a bunker to another bunker. Okay. The most interesting thing is that this machine, like the dosing machine and the charging crane, they work together. This is is not easy to see, but once that the recipe is selected, this is basically a standard recipe with steel, pig iron, and returns and so on. And this recipe is delivered to the crane and also to the dosing machine. The dosing machine, we will see later, works together with the crane. Okay, so the target is to not to fill that specific amount of material, because this is practically impossible. If you use, for example, a big chunk of steel, okay, you can have some variability into the difference in terms of the real weight and the targeted weight for each material. What is important is that the system automatically compensates the ferro alloys in order to reach the chemical and physical targets of this charge. Okay, and this is exactly what the system does. So this is the homogenization process. OptiDose. The OptiDose is a range of machines, very custom machines. So normally we can classify this dosing machine, vibro dosing machine, in 3 different categories, families. For the base iron, talking. The one for the base iron is a centralized dosing machine with a monorail that deliver the mix of ferroalloys directly into the charge cars. This is a new concept that we have developed. Is a quite successful concept that is a decentralized system. So basically, the most part of the foundry, they have medium frequency induction furnaces. Normally they have 2, 4, 6 or whatever. So this machine works every 2 furnaces and is able to deliver the material left and right. So basically is placed in the middle of 2 charge cars. And we will see why we have done this solution. The other dosing machine is normally for dosing in material in ladle, so ferrosilicon, magnesium, and cover material, or just corrective material. So this is an example of the OptiDose. For example, this is an installation for in US, and is an automatic big bag system for filling the right silo. And here there is the monorail bucket that collect the material from the vibro dosing system and deliver to the furnace. This is a very traditional system. We have not invented this system. It's quite common. Many companies, they do this. As a big limitation is the speed. Why? Because the approach in base iron production is always the same. A recipe, the system has, the operator has to follow a recipe, and the dosing machine has to follow a recipe. And this machine works perfectly in this mode, but it's very slow. So if you consider that this bucket has to collect the material here, goes up, and then goes deliver on 40 meters and then go back, okay? So you need 5 minutes, 6 minutes only to reach the target. This is important if you want to use a dynamic mode. What is a dynamic mode? The dynamic mode is this concept, okay? When we select a recipe in our logic, we charge fully the charge cars, but not the ferroalloy dosing system. Normally, there is a parameter, can be 80 or 90%, but we prepare the ferroalloy mix only 80% for each material, not more, because the last amount is calculated in function of the real amount of raw material that the crane put inside the charge cars. So, but we don't want to delay the production, so the melting of the iron. So what the system does, we need a dosing system that is very, very fast in preparing and also delivering, okay? And this is the concept of the decentralized solution. The decentralized solution, every single material is measured at the same time. So there is a measuring system, a weighing system for each material. Each material and a specific weighing system that is function of the amount of the material. So for graphite and ferrosilicon, we will have a very powerful vibro dosing system. But for ferrochromium or other materials that you normally put in a lower amount, the weighing system will be smaller. Smaller means also more accurate, okay? As an example, in the centralized system, so the standard system, normally you have a big car, okay, with the load cells on top that move from a silo to another silo. So ferrosilicon, then graphite, every step make it zero and then collect. So this car normally weighs 1.5 tons, okay? Imagine what can be the accuracy if you have to dose 5 kilograms of ferrochromium, okay? It will be very low. This is a very important concept. So what we do is we customize the measuring system for each specific material in function of the normal amount that you put inside. So in this case, the system is able to prepare the final mix dynamically and to deliver very quickly. I will show you just a little video of this because it's a real video, is the simplest solution. Oh, sorry. No, smoothing the others. Okay. So what you can see here is selecting recipe. This is the crane. It's visible. It's not so far from Venice. It's a foundry very close to us. It's a former Electrolux foundry. The crane collects the material, makes all this operation. They are done completely automatically. So also the trimming of the material, so the measure, and it's delivered. See that the charge card is divided in 4 positions, and we can target the specific position. Here you can see the dosing machine. The dosing machine is in the middle of 2 cars. In this specific foundry, we have 2 ABP furnaces, 23 tons each. Okay, so it's a big, and then they have another 2 12 tons. So the dosing machine has independent weighing system for each chopper and a car that can shift left and right. So in this case, the car collect, shift left or right, and deliver quickly the mix. So we don't need the monorail to go up and to move to the target furnace. This is, if you want to have a dynamic approach, this is the only solution because it's the fastest solution you can have, okay? Another important aspect of this system is that because you have independent weighing system for each material, you can be very, very accurate, okay? So I have a 50-liter hopper if I need. I have 200-liter hopper for graphite or whatever, okay? What is the other advantage is that you can use the same ferroalloy dosing system also for trimming the liquid iron, because it's very accurate. Okay, so you can also dose very little amount of graphite, ferrosilicon, or whatever. Okay, so this machine normally has a 3 output: left, right, and in the middle there is another exit for the material that in this foundry, for example, they use for preparing, see this pipe, preparing the mix of alloy to trim the iron when it is ready. Okay, when the iron is liquid, you make the correction. So the advantage is that every single material is traced. So all the addition of steel, pig iron, or the raw material, but also the ferro alloys, everything is traced and enter inside a system. In this foundry, for example, we receive also information from the furnaces in terms of power, energy, and this information are connected to the output of the system. The output is the physical and chemical parameters of the iron. So you imagine that you charge this material, you use this energy and power, and you obtain these results in terms of physical-chemical parameters. So position in iron carbon diagram, chemistry, and you can predict using this algorithm like machine learning that works very, very well in this specific application, because you can, after a while and few months, okay, you can already train the system in order to predict what happens if you use a specific material, or the contribution of every single material on the final effect. This is a very important aspect. Okay. So it's sorry, because I'm going fast. If you need specific information, the MELDEC is a thermochemical analysis system. Sorry, it's not working here. Okay, so we have charged the raw materials. We have added the ferro alloys. Now we have to control. The logic of MELDEC is very simple. You take a sample. Normally, you take with a spoon. You take tellurium, non-tellurium cup, and spectrometer or Leica, whatever you have, and temperature. And you can create a list of parameters that are the parameters that you think that, in order to say this iron is deliverable, has to be in target. Okay, so normally we go from 15 to 22 parameters. 22 parameters, as an example, is Brembo everywhere. So Brembo has different production processes. For example, in Italy they have cupola. In other countries they have Juncker furnaces, inducto. But they have also different molding line and so on. But the procedure for controlling the iron are all everywhere the same. Okay, the carbon has to be in that specific position, eutectic temperature in that specific position, liquidus temperature in that position, and so on for the chemistry. What the concept on the MELDEC is very, very simple. So these procedures are created, and the iron is deliverable only when all these parameters are inside the acceptability range. The target is not to make this acceptability range too narrow. The target is to make acceptability range as wide as possible. Okay. What is important is that if you stay inside, you are safe. And for example, in some foundry like MTI, is an American group, we have an automatic ladle transportation system. And if the furnace is not in range with all the parameters, that furnace is invisible for the aerial transportation system. Okay, this is clearly the best solution. So how the concept makes: you charge, you control, you trim, and you verify, and then you approve. So the concept is you have a list of parameters that have to stay inside the range. If a parameter is not inside the range, the system is able to tell you what is the action that you have to do, okay? And this action can be basically addition of ferroalloys or temperature. It's very simple. You can also create the action too. So the system suggests the measures, how much ferrosilicon, graphite, and to add in order to enter inside the acceptability range, and you can send directly to the dosing machine the corrective mix. Everything is traced, okay? Scale. Every single machine in all our network has 4 lights. So for example, furnace, pouring furnaces, or in no-bake foundries also in a specific position of the factory. The green light means that all the parameters are inside the acceptability range. The yellow one is yellow. The red, at least one, is completely out. And then the validity time. The validity time means that in a procedure, you have a parameter and you have a source. For example, eutectic temperature, source, thermal analysis, silicon, source, spectrometer. Temperature, the probe, or can be the probe from the melting furnace too. So the concept is that every single source has a specific validity time. So if you want that the operator check that specific source every 10 minutes, or every 30 minutes, every 45 minutes, this depends by your process, the few minutes before that the time expires, the blue light start to flash. And if the operator doesn't make the check, the blue light becomes solid and all the other light disappear. So basically crossing through the foundry and seeing this light, you can understand if the base iron on furnace 1 is inside is okay, or the final iron is okay in that specific moment, specifically for this casting that you are pouring, okay? So this is the concept. It is possible for the operator to force a not green light in a green light. In this case, the green light will be a flashing green light, and the operator can select from a list of reasons that you have created for him. Like, for example, the temperature is not in range because I'm giving power. In 5 minutes, it will be in the range. So this is an example in which you have a very basic procedure. The system suggests how to check, and you enter inside the range. At the moment of this system, we have installed everywhere in the world approximately 120, 130 systems. Okay, normally quite complicated system also. So OptiDose for this is an example. In this foundry, we have created this aerial transportation system. This is MTI, sorry, in Mexico, and this is a completely automatic foundry in which we have also this automatic alloy dosing machine that put ferrosilicon, magnesium, and cover material completely automatic. This is the foundry in which I have also a video. Let's see if it starts there. No, it's not starting. It's starting somewhere else. Okay, let me. Aerial transportation system for us are this system. Okay. The resolution is not. Okay. So this is the first installation we did 13 years ago. Is an automatic foundry that was the first one that we did. close to, so there is a ferroalloy dosing machine. This foundry, the only possibility to correct the iron is here because they have rotative gas furnace and an holding furnace. So they add the ferrosilicon, graphite, and preconditioning and pearlitizer automatically. The ladle goes to a correct wire station in which we do ferrosilicon magnesium treatment and inoculation system, inoculation also. And then to the slugging and to see, in this case, the correct wire station goes on top of the ladle in order to minimize the cycle time. This ladle can process from 1.6 to 2.6 tons. And the cycle time is around 7.5 minutes. So after the treatment, it goes to the deslugging and then automatically to the pouring. We have done a lot of this installation. This is a mix of this is Daimler. We have in South Africa, Atlantis, you know very well. This is one of the most advanced systems. So it's not a monorail loop, it's an open loop. And for this reason, and we have two carriers. This is able, every carrier is able to process the whole production of Atlantis, that is 36 tons per hour. But we have two. And it is possible for one carrier to cross the other. So the carrier now is going from the holding furnace to the deslugging, and the other one comes back from the pouring. And we have created two switches. This is the first switch, in which you will see that now this carrier goes to the holding furnace to take the iron. So this is the place in which the two carriers, they can cross each other, okay? So this is during the commissioning phase. So it's a little bit, the carrier is not fully fixed too. Okay, so now this carrier will go to the holding furnace and the other one will go to pouring. And because the pouring furnace is moving in this foundry, we have another switch. So when the carrier arrives, we receive the position of the pouring furnace, and automatically we refill the iron inside the pouring furnace. So the maximum potential of this installation is around 55 tons per hour. So now they have done the slugging, they are measuring the temperature, they remeasure the temperature again. So, and see, this is another, sorry. This is another switch that is able to follow the movement of the pouring furnace. Now they will check again the temperature, and after the approval, the system will fill the pouring furnace. So the guy now is arriving. So this was commissioned in 2023 and was the biggest one we have, but now the biggest one will be John Deere. John Deere in US, we are installing it together with the Juncker in Duga for pouring a much bigger system. It's able to supply up to 82 tons per hour. This one is a medium-sized foundry, also a very narrow place. So it's an automatic crane that is completely automatic. It's close at the area. You fill the iron in the ladle. Everything is controlled by Ithaca. So we register, Ithaca suggests how much? 2.2 tons, okay? The operator fill manually the iron in this case, automatically goes into the cored wire station. The cored wire station add only the amount, the exact speed and the amount of cored wire for reaching the magnesium in the ladle that we need to reach the target in the pouring furnace. They have a 8 tons pouring furnace, okay? This is MTI, automatic addition of ferroalloys. This was the biggest installation. This is a 3 carrier now, in the video still 2, but we are commissioning in these days the 3rd one. And this carrier is a huge carrier. This is a 3.6 tons ladle. Just to understand the carrier, the total carrier weight for each, see here, you see the other carrier that is coming back. Each carrier weighs 32 tons, okay? And no columns, everything goes on the roof, is on top of the roof. It's a crazy installation. but very successful. And now in this video is supplying the iron to two disamatic lines, but since next year there will be the third disamatic line and the third carrier. Also in this case is completely say automatic. Clearly the only thing that you cannot automatize is, for example, the filling of the pouring furnace, because if there is something that block, like the siphon is clogged and so on, you need the operator that maintain a button pressed and release the button in case of emergency. Okay, so this is another say product that we have is the ladle, the LTS system, so the aerial ladle transportation system. We do also ground transportation system for Volvo, for example. We have done a ground transportation system, but our favorite solution is the aerial transportation, because it's safer, even if the people think differently, but it's much safer. Every single movement is redundant in our system, aerial transportation system, and then all the mechanical, all the electronic is far from the iron. So in the ground transportation system, if you have an iron leakage, for sure you will have big troubles. In the aerial transportation system, the level of maintenance is exactly like a crane. Okay, so no more than a crane. Let me understand how to, okay. So I go a little bit faster. So wire, I know that the UK wire is not a favorite solution. I like a lot wire, even if we are very objective. So we do ferrosilicon-magnesium alloy station, like the one that we have seen in NTI. I like a lot to wire. I like a lot if you are thinking to automatize the process. In this case, our approach is always the same. So making something that is very dynamic, and the wire in terms of dynamicity is the best. What I like a lot about the wire, and the wire that is from some point of view was very, very similar to ICME-Technical converter. So in ICME-Technical converter, the logic of ICME-Technical converter was fantastic. Now, to put the preconditioner inside the ladle, let the preconditioning to react, and then only after to make the treatment. Why? Because you need time to activate correctly the nucleation. With the wire, every addition you make in the ladle works very well. Every addition, because you create basically a new corrective phase compared to sandwich or tandish process. Again, I'm not in favor with colored wire or sandwich. In John Deere, we are working with a tandish. In NTI, we work with a sandwich process. So for me, it's really the same, but taking consideration of these advantages. Clearly, the disadvantage is the cycle time. That can be, if you are already squeezed with the cycle time, it will be very difficult to place a colored wire system. Okay, so this is some picture of many stations that we do, and let's keep this phase. The aerial transportation system we already talked about. So monorail, crane, or even car drive system for a ground transportation system are okay for us. Okay. Let's proceed. ITACA Stream XL. This is for example, this is a picture done in William Lee. Again, also in this case, dynamic addition. The leitmotif is always this. In William Lee and in Custom PLC, we have installed this machine. The target of this is to measure how much preconditioner you put in the ladle, and to make it as dynamic as possible. With this machine, it is possible to make more dynamic. You can also make automatic, say, solution. Like, for example, you want a level of preconditioning that is 0.2% at the beginning of the melting furnace, and then longer is the time that, and higher can be the amount. So if you have an oxidation factor of the furnace, you can automatically increase from 0.2 to 0.3, from 0.2 to 0.4, ladle by ladle when you empty the furnace. Or, for example, when you hold the iron too much, you can automatize the increasing of preconditioner in the ladle completely automatically. Basically, in this case, I'm talking about the solution in William Lee and Castle PLC. There is a weighing system, a screw, a silo, a screw that fill the inoculant inside an hopper. The hopper, we measure the weight, and then it is discharged progressively during the filling of the ladle. There is also a system to control if the pipe is clogged or not, in order to give a sort of approval to the process. The Ithaca Stream XL is also used a lot for this application, for big molds. We put the steam inoculation device on top of the mold. Okay, we have sold this to Caterpillar and to, for example, Shrem in Poland. So there are systems that you can put on top of the molds, and you can use as a stream inoculation device for big castings. Can be controlled with a radio control, so you can define how much the flow rate, how much inoculant you want inside, and you can also pre-charge a pouring curve in this machine. So final iron. Also in this specific field, we have some customer UK, like URAC, for example, use these systems. Okay, the pouring is the same concept. This is a screen. This is the supervisor of pouring. This is the screen of Ithaca for the pouring side. Every single of this is a mold. Okay, so basically, what Ithaca makes for the foundry, collect all the information. So thermal analysis is inside the system. Chemistry from LECO or from a spectrometer. Sand properties, inoculation properties, and pouring also parameters. And for each mold, see that all the parameters are inside the acceptability range. If only one is outside, you can have say yellow or red alert. Very important of this. Then we have developed some sensor for this specific issues. But what is important is the alert. The alert is the most important thing, concept in Ithaca, is you can create as many alerts as you want. The alert is the combination of the status of parameters coming from different sources, because the problem in foundry never come from the single source. As an example, the cold junction is a combination of low temperature and high liquidus temperature of the iron. So when the difference is too low, the viscosity become too high, and then you have problem of but the temperature comes from the deep probe or the pyrometer, and the liquidus come from thermal analysis, and you have a lot of different parameters coming as a combination between sand properties and chemistry, for example, pinols or whatever. So you can create as many alerts as you want. The alert is the combination of parameters. So, for example, an alert is if the liquidus is higher than and pouring temperature is lower than cold junction. Okay. And you can create the alert and for a specific casting. So if a casting has a specific sensitivity to a probe, you can create this alert only for that specific casting. Every time that this condition will appear again, you will have the alert before. Okay, so, and this is the most important. The alert is in this section, and you have the current alert. Just understand that we started the process not from the equipment, but our know-how was mainly on the process. So we have created the thermal analysis system, and later we have developed the machine. So this is very important because we have created the equipment, the sensor, and the machine in order to solve the problem that we were facing into the process. A good example about the difference between these two approaches, as an example, the cementite. If someone of you has a thermal analysis system, you know that for the thermal analysis system, you have the cementite when the authentic temperature is lower than a specific value that you set for a casting. In Ithaca, the cementite is an alert, and the alert, you don't have this alert when the authentic temperature is over a specific value. The inoculation, the steam inoculation machine say, okay, I put this inoculant inside. The camera see that the inoculant is really entering into the stream, and the demolding time is inside the acceptability range. Only if all these parameters are satisfied, the system say you don't have cementite. So this is the difference. So you cannot say the casting has cementite or not only with a cap, because if the steam inoculation is not flowing properly inside the stream, you have cementite. But the iron in the cup is perfect because you put the spoon of the inoculant inside the cup, and the dilution is perfect. So the concept here is a little bit different. So we have developed this group of machine, okay, or sensors. Like the sensor, the pyrometer is normally we use Keller pyrometer, but we have created a specific software on top of this pyrometer. And Ithaca Vision is a camera for controlling 30 times per second the distribution of inoculant in the stream and also outside the stream. And Ithaca Stream is an steam inoculation device that is apparently similar to the other, but in reality has a stepper motor, and the pipe is moving and is able to follow the iron stream, okay, constantly. So when the iron stream has a little deviation, so for example, for slag, this is very common everywhere. You will be surprised if you install a camera on your process, you will be very, very surprised. Okay. Also, this system you can see in MIT. I think they have two in UK and other in the other plant. I want to show quickly some. Yes, this is the base of casting. So every time the system normally is installed and connected automatically to the molding line or to the pouring furnace. So we receive the information about the casting, and we adapt all the acceptability range and parameter in function of the casting that you are pouring. Alerts, I explained, this is an example of alerts. So this is a typical procedure of a final iron. So everything has to be in range. So you have physical parameter, you have chemistry, you have sand properties, and temperature, and so on. The vision, this is something that I want to show you because I know that I think that you don't know. This is a camera, and we developed for the first step of this project was with Fosico. So the first prototype was developed in 2010. Now we have reached really a very good result. So the camera is able to measure every, I will show a bigger picture. Okay, this is more clear. So it's able to measure every single position and dimension of every single particle of inoculant, okay, 30 times per second. Our camera use 50 frame in, say, natural light mode and 50 frames in overexposed mode. So basically we make 1 and 1, 1 and 1. So in the normal mode, we see the inoculant on the iron. In the overexposed mode, we use the light emitted by the iron to highlight the inoculant that is going out of the iron, okay? And this is done 30 times per second. So the system is able to see how much inoculant there is and if it's perfectly aligned to the stream. Okay. So these are some pictures. This is a Draxton group in Spain, and this was a very strange period of time. So for 15 minutes, this is a D-somatic, so it was perfect, and then he was moving left, and then for 15 minutes it was distributing inoculant like this. Okay, but they never have seen something. They have scrapped. They try to understand what happened, but they will never be able to understand. Okay, and then after a while, he went back again because, for example, when you have slag on the nozzle, even a little variation can produce this effect. Then it cleans itself, or they clean us. But this is what happened. Every single of this point is a mold. So why this system is very important in my opinion? Because for each mold saves a lot of picture. You need a lot of space, a big hard disk, I can say. But when you have a doubt about inoculation, you can solve this doubt using a real picture and real measurement of every single frame. So you have a movie for each mold. This is an example. This is the standard mode, and this is the overexposed mode. So you see that using the light emitted by the iron, we can highlight the inoculant that is going out. So we can understand very well if the pipe is centered or not. There are also other things that this system makes. For example, measure the turbulence of the stream. So clearly, this stream is very, very laminar, okay? The laminar is a rectangular shape. This one is absolutely far from laminarity. So the system measured a laminarity index. Also, this laminarity index was created the first time for the Pittsburgh University. And at the moment, our first prototype is working in a German university for measuring the efficiency of the stopper design. Okay. But what happened, for example, here is that the most part of the inoculant is inside here. So when many times this iron split in two parts, you cannot see with your eyes, but and the inoculant goes into the center. So you think that you are inoculating at 0.1%, but at the end you are inoculating 0.05 if you are lucky. Okay, this problem clearly is a big problem in D-somatic. Okay, in big molding line, this is not a problem. Okay, so I go far. This is another example of the dual frame. Probably I have also a video. Yeah, so this is how the system works. So measure, and here you have how much inoculant in the first chart. Sorry, I cannot find it. In the first chart, how much inoculant there is inside? 90%, 100%. Here is the misalignment, so the axis of inoculant compared to the axis of the iron, and here is a mathematical parameter, is the ratio between the inoculant and the iron, okay, in terms of surface, because this system is not able to measure in terms of percentage, because at the end we have a 2D pictures, not 3D pictures. So we don't see the 3D shape of the stream. Okay. So here is you can analyze just to show you can analyze the data on long term. Yes, every single of these little point is a mold. So this is one shift production, the other shift production, and for each mold you can see if there are problems, what kind of problems there are. You see these little triangles here that show where there is a problem. And here you can see the whole video of this specific mold. See that in this case, the inoculant was on the other side, was not centered. This is a common situation in almost all the foundry in which we go. Okay. Another important thing is that this was clear. The synchronization, the system measure what is the synchronization level between, so the first frame of iron is already inoculated or not, how much is inoculated, okay? So the system measured the delay in second divided by 10 for the inoculation. This is the stream inoculation inside the machine, just to show that it is very easy to remove, and you don't need any tool to remove the screw or to make some maintenance. Okay. So this is the presentation connected to the products, Vision, Stream, and say all the Ithaca family product. I want to show also the presentation about the Arena product. How much time I have to travel? 15. Okay, I go faster. Sorry. Okay. I don't know why it started from here, but. Okay, again, also in this case, we are talking about automatic deep tanks, drying ovens, and the process also connected to say, coating and drying. This is a chart that measurement test that we have done with using the wet layer thickness as a reference, and show you how, for example, this, sorry, I can't find my mouse. This is the descending time, so the time that the speed that you go inside a deep tank, the time that you stay inside the deep tank, and the time that you need to go up, okay? And the wet layer thickness that we have measured in each step. As you can see, the descending and the ascending time is not so important. What is important clearly is the time that you stay inside the coating. Another thing is the effect of the density on the wet layer thickness. So if the density is 1.21, 1.26 or 1.29, the effect clearly is very, very strong, as we expected. This is very important because the sedimentation inside a deep tank produce exactly this effect. Okay, so this is measurement of wet layer thickness using manipulator manual, or for example the flicking. Our manipulator, if you use a manipulator to go inside the deep tank, the variance is very, very low. Okay, we have developed these deep tanks. I will show immediately how they work. Okay, so the concept is here is to produce a coating automatically with the constant values in terms of density and viscosity. So we apply the same concept for flow coating station and for deep tank. So in this case, this is ferromatrix, big cores, but also molds for this application. And here you can see how it works. Okay, so the concept is this. So there is a tank in which the coating goes back, and inside this tank we add coating past, water or alcohol also, in order to maintain stable automatically the density values and also the viscosity in case the customer has a specific request. For example, in Brembo, the control procedure, they use not density and viscosity together. Okay, they don't accept only density. Okay. Here we can see how it works. Just a flow coating. I can show the video together also. It's a foldable tank. Okay, so the coating preparation plant works exactly with this principle. You can use it, for example, engine blocks in Scania, Daimler, also Georg Fischer. They use all these kind of tools. Okay. And this is a manipulator. This is I don't remember. It's a German foundry. And this is Van de Wille. So this manipulator, you can control the speed, the time, and you have a specific recipe for each course. Okay, so we control the density inside the tank, the viscosity inside the tank when it is required, and all the other parameters, so the dip time, the lowering time, the dipping time, and the ascending time. One of these systems is installed in William Lee too. With Fosico, we did the first one was in Forge Master also for the big flow coating tank that is still in use. UK, no, we don't have other installation of these systems, no? Okay. Okay, we go. So this is William Lee. Okay, so this is just to show you that it is possible to use this tray, this manipulator in many different ways. In this case, for example, it makes dipping, but also remove the drops of the coating. So you will see now makes a specific. Here there are so many samples. We have done really a lot of these machines. This was in our company, but you can make many different things with the same machine. This is SLR in Germany, in Esterheide. So in this case, we don't have any manipulator, but the quality of that coating is always the same. As an example, in hot countries like South Africa, hot as a not properly clean countries like in South Africa, in India, for example, India is a disaster. All the water that is injected in the system in order to maintain stable density and viscosity is disinfected. So we have this UV treatment system that in which we remove all the bacteria to avoid bacterial attack. This is another thing that we do is what we call multi-cell. This can be also interesting for your foundries. It's a concept, it's a different concept. Normally you have the core shooters, you have the deep tanks on board, and you have this drying oven that just one is used for all the production. In this case, we have done this autonomous cell, is a robotic little cell, also relatively cheap, and that inside the cell you have the robot, the automatic deep tank, and also a little drying oven. So it's a cell designed only for a specific core shooter. It works for one, maximum 2 core shooters. The shape of the furnace is rounded. So the robot basically plays the wet cores, and the wet core make a circle, and then immediately close to the wet you have the dried cores, and the same robot make dipping, in some case gluing, place on the drying oven, take the dried cores and palletize. So basically you don't touch the cores, okay? You don't have any operator. The only thing that the operator can do is to remove the pallet and to feed eventually the robot. Okay, also this, so you see this is the furnace, let's see. Yeah, so it's charging the cores. This is another logic. So the robot doesn't take out directly from the core shooter, but because it's making gluing also. We have also even an installation in which make gluing and screwing. And then see, in the robot, you have on the right part, you have wet cores, and on the left, you have the dried cores. This case, okay, is the operator, but the robot can be also, can place directly on mount. Okay, can be a rounded, but can be also a linear furnace, like in this case, in which the robot takes out from the core shooter, dip, and place on the drying oven. The drying oven is very short and cheap drying oven, 2 levels, up and down. It's very short, it's 3 meters, not more. Okay. This is another simple machine, is a vibro filter for removing every single part of sand particles from the deep tank. Okay, this you can use it as a dialysis. Okay, so you can clean. You can use only one of this machine, but you can connect to many deep tank 1 hour per day, for example, and is able to remove every single particle of sand. So you don't need to clean the tank frequently. This is used, for example, for in no-bake foundry for just avoid sand particles on the surface of the core, but even for cleaning the deep tank. It works in this way. I go faster, it goes. I don't know. So it's machine like this, is a movable machine, and you connect the fast connector to the deep tank. In this case, it's our deep tank, but can be also your deep tanks. And you let him work for 1 hour. So basically, we have developed this electric pump that works instead of a diaphragm pump. So it's very silent, very efficient, and a very long life, and is able to remove, as you can see, you have here is not clear, but the coating enter here, and from this output, the sand particle goes out. The other coating enter again into the deep tank. So, and the system, yes, you can remove these, even these sand particles. Drying, we do a lot of drying. Oven, Daimler we have done. All the Brembo in the world use our drying ovens. Yes, we have a lot of these drying ovens. So this is the simplest solution for little core shooters like this. but we have also, for example, turbochargers, high efficiency system. In this case, this is Daimler in South Africa for engine blocks. And we do also strange solution for no bake, like, for example, this system for drying movable furnaces that you put on top of the cores. This is Caterpillar Kiel. And also in Mapleton, US, we have a similar system. So they are drying panels. They use infrared plus air, a lot of air, because we use axial fans. So low pressure, but a lot of air. Mixed combined with infrared, they are able to dry big molds or big cores. Yeah. For example, this is Ecufren. We have delivered 2 of these vertical ovens for brake disc. With robots, so directly again from the core shooter to the drying oven, with our deep tanks also. Deep tanks is not easy to see, but is there. In this foundry, they did not have enough space for placing a long drying oven, so we went up to 11 meters. Yeah, so here you can see. Okay. This is Proferro in Belgium. This is a multi-purpose drying oven. In this case, all this roof here, we use the energy coming from the cupola, so the diathermic oil, and we use to dry the cores. Okay, so we recover the only moment in which we use the gas burners is when they don't have enough diathermic oil, but otherwise it's completely say cheap, zero consumption of natural gas. And you can easily you can put what you want, big cores, so you can put a steel pallet on top of this. Is very flexible. This is a Scania. We have delivered 2 of these drying oven for engine blocks, huge furnaces, so divided in heating and cooling here, and also the deep tanks. And this is a new generation of furnaces for molds. These are for Mexico. Is a Japanese company, Maekawa in Mexico. And for example, even the axial fan is completely done by inside ProService, because this is customized for this specific application. The logic that we use also for brake disc is very similar to Dyson air dryer. No, so Dyson air dryer works at low temperature but move a lot of air. Okay, and this is exactly what we do in our system. As an example, in the first furnace drying oven that we have delivered in Brembo in 2004, the drying temperature of the brake disc for car was 140 degrees Celsius. The new generation, we dry 85 degrees. Okay, so clearly the losses in terms of the energy loss is much lower. So in terms of efficiency and cost of the machine is incredibly low. And we use axial fan. The axial fan, they move a lot of air with a very low amount of energy. Centrifugal fan, they have move less air, but with you need a lot of power. Okay, so the concept is very similar. Okay. I finish here. I don't know.
Okay, thank you very much. Thank you very much. Do we have any questions? I've got a question. So you've done a lot of innovation here, I can see. What's next?
Next, we are developing these the grinding machines. They are almost ready. The first one that is will be a Koyama style machine, so Scara. Will be ready in 2 weeks. and we will start the testing phase. But before March, we will have a complete range of machines. So the engineers, they are working. So linear machines, the robot, we are more advanced because we have acquired these engineers from Mouse, but also from another company. The name was QD, and they were very specialized in robotic applications. We needed a robotic engineering office inside ProService for all these independently by grinding. So we have joined this the software. So what we have realized is this system, the name is Colibri, is a very easy, user-friendly system for programming CNC and robot for grinding. So it's a system that you can make a program in 30 minutes for very complex casting, like for example frames for CNC machining. So it's and it's only for foundry, for the foundry. It will be presented the beginning of the year. Okay, and the other thing we are doing is this thermomechanical sand reclamation system. That is also our dream. We have designed this during the pandemic period, and we have already installed a machine. The first one in Italy is 1.5 tons per hour, so is able to reclaim 10,000 tons of sand per year. And this week we are installing the 5 tons per hour system. Is the big one in Erkunt. And the installation will be completed in the end of January, as you can see. And this is able to reclaim approximately 30,000 tons per year. Yes, it's not like Omega system. It's not mechanical, but is a thermomechanical system. So with many advantages and few disadvantages. Also, in this case, for example, this is not a new machine, was already existing, this kind of machine. There were also an American brand that was producing this, former Simpson engineer. There was a FATA that was making a system like this, but the status was of the art is 25 cubic meter per ton of gas and 90 kilowatt per ton of electrical power. In our machine now we are working with an average of 8 cubic meter per ton of natural gas and approximately 35 kilowatt per ton. So the machine, the advantage of designing a machine in in this period is this one. You can work more in the direction of higher efficiency and so on. Yeah.
Last chance. Any questions? No? Mark, can I ask you to do the vote of thanks?
Well, Toni, thanks very much for a comprehensive technical talk. My first notes was the sort of deep understanding of melting, production, foundry requirements. But then you went on to coating and drying, and obviously answering Trevor's question, you've also got a bright future with robotics, thermomechanical reclamation, and overall, I appreciate the fact that your systems give us better controls and better traceability. So thanks very much. We'd like to thank you in our usual way, which is a round of applause. Thank you, Toni.
Toni, do you want to run your slideshow? Or, Tony's just going to set up his slideshow, so while we wait to see what...
yeah, okay. Well, if you're like me, you're probably ready for something to eat as well now. And certainly Nicola's English is far better than my Italian, so I applaud his ability to be able to speak our language better than me. So what I intend to do is just simply put on something about what TE-TEC does. It was formed nearly 2 years ago, was active, operational 14 months ago. And during that time, the company's connected with 14, mostly Italian companies, selling capital equipment and also consumables. I'll just roll it round whilst we have something to eat. So that's all I have to say. Thank you.
Thank you very much. I'd also like to thank Toni for sponsoring this event. So thank you very much for that, Toni. We've got a couple of notices. Next week on Tuesdays, Branch Council. We keep asking anybody wants to come along and